We are working on lesson 1.2 today, and we're going to be discussing the differences between observational studies and designed experiments. And to do that, we have to talk about the two different types of variables that we're going to be working with. So far in units, a little bit of 1, 2, and 3, we've just only discussed information about one single variable, and now we're going to be talking about two variables that are interacting together. And the first is called the response variable. It's also called the dependent variable or measured variable. Is the particular focus of a question in a study or experiment. It's what you're trying to find out about. This variable is usually associated with the letter Y. The second variable is the explanatory variable. It's also called the independent, or sometimes called the predictor or control variable. Any factor that can explain variations in the response variable in an experiment, it is manipulated by the researcher. This variable is usually associated with the letter X. A treatment, it's an explanatory variable that takes the form of a purposeful intervention in a designed experiment. Often treatment is a combination of many factors. And it's not necessarily, when we hear treatment, we think of something medical, but that's not necessarily true. It could be two different types of brakes on your car, okay? Observational study is a study where the researcher merely observes what is happening or what has happened without manipulating the situation and tries to draw conclusions based on these observations. Surveys usually fall into this category. Designed experiment is a study in which a researcher manipulates one or more of the explanatory variables and tries to determine how that influences the response variable. Note, studies where researchers randomly assign individuals to groups falls into this category. So let's look at our first example. It says a team of veterinarians wants to compare the effectiveness of two fertility treatments of orangutans in captivity. The potential treatments are in vitro fertilization and fertility medications. What is the response variable? And the response variable is pregnancy or not. We're going to find out if they actually have are fertile. What is the explanatory variable? And there's two, they said. One is in vitro, and the other one is just fertility medications. Is this work an observational study or designed experiment? And we're going to kind of assume it's a designed experiment only because they didn't tell us that they randomly put them into groups, which is also part of being a designed experiment, but because there's treatments, it's designed. And how many levels of treatment are there? There are 2 levels of treatment. Okay. When we're looking at experiments and studies, we could have some confounding variables. Confounding variables occur when the effects of 2 or more explanatory variables cannot be separated. Therefore, any relation that may exist between an explanatory variable and a response variable may be due to some other variable or variables not accounted for in the study. Lurking variables is an explanatory variable that was not considered in a study, but that affects the value of the response variable in the study. In addition, lurking variables are typically related to explanatory variables considered in the study. So a lurking variable could be the heat outside. And we will continue to see this example. The heat outside could cause people to make a rise in ice cream sales, right? Summertime, springtime, people love to go to get ice cream. When it's hot outside, it's also well known that crime increases, okay? But they might, because when the heat goes up, these both increase. Sometimes there's a joke that ice cream sales causes crime, but we know that that's not true. It's just they're both kind of related to this heat outside. Confounding variable is an explanatory variable that was considered in a study but whose effect cannot be distinguished from a second explanatory variable in the study. So lurking variables tend to exist in observational studies. Confounding variables tend to exist in design experiments. Let's look at our second example here. Researchers wanted to identify the effects of music on intelligence. An elementary school was identified that held an enrichment program at the after-school daycare. The children at the school with the specialized music program outperformed children at a neighboring elementary school in cognitive abilities. Is the study described an observational study or experiment? Observational. There's no treatment. Where they randomly assigned. Okay, so we can say there was a treatment, and the treatment is, they could kind of say that's because they either had the specialized music program or they didn't. But they were not randomly assigned to that, so we can't say it's a treatment. Why does the study state that the other school being compared is a neighboring elementary school? So we can know that the children probably have similar demographics as far as maybe household income, where they live, access to food, access to schooling, things like that. But it says an elementary school was identified that had an enrichment program at the after-school daycare. So it could just be two public schools in the same city. One offers the after-school enrichment program, the other one doesn't. Based on the results of this study, would you recommend all children study music? I would say it wouldn't hurt. But we can't say definitively because it could just be, it says with the children at the school with the specialized music program outperform children at a neighboring elementary school in cognitive abilities. I mean, there could be other things. It could just be those parents worked harder with their student, you know, their children at home. So we don't really know. There's definitely other variables. Fill out the lurking variables are there. So, and we know this is, we said there's lurking variables, and lurking variables tend to go with observational studies. So higher cognitive abilities, and it's an after school, so more time on task, right? So more time on task is what really could just be causing the cognitive abilities. And more time on task means that they're having the extra music program. So it appears that the extra music is causing the cognitive abilities to go up, but really it could just be the time on task, more time spent working on the music. Okay, so we're going to talk about observational studies here for a minute. There's 3 types of observational studies that we're going to like specifically talk about here. And one of them is cross-sectional studies, observational studies that collect information about individuals at a specific point in time or over a very short period of time. So that's one thing we have to remember, a very short period of time or a very specific point in time. Case control studies are retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records and gather information. The third is a cohort. A cohort study first identifies a group of individuals to participate. The cohort is then observed over a long period of time, so that's different than a very short period of time. Cohort studies are prospective. Prospective, they're looking forward. Retrospective means they're looking back. So this means they're looking back. This means they're looking forward. Okay. A few other sources of observational studies. One is a census. A census is a study that obtains data from every member of a population. In most studies, a census is not practical because of the cost and or time required. We have the US Census in 2020. Web scraping is the process of extracting data from the internet. And anytime you're on Facebook, Google, Twitter, Instagram, they're all collecting data on you all the time. And then there's publicly available data. Government agencies, companies, sports organizations, etc., regularly make their data publicly available. And here are some websites that you can look at if you'd like to. Let's look at example 3. Example 3 says, we're choosing between explanatory and response variables. We're looking for those. And then we're deciding if it was an observational or designed experiment. And if it's observational, what type is it? Cross-sectional, case control, or cohort? So it says, I'm going to let you read through here. I'd like you to take a minute, pause this and read through A, B, C, and D, and decide what you think the explanatory and response variables are, and whether or not it was designed experiment or observational, and then which type of observational study it might be. So go ahead and pause for a minute and do that, and then when you come back, we will go over them. Okay, we're back. So in this first one, we're saying that the location is the explanatory variable, and the percent who earned a degree is the response. And this is an observational study that's case control, because they just went back and looked at the records of some students. The second example here, at the example with the McDonald's fries, is the flavor type is the explanatory, and the taste test is the response. And this was a designed experiment. And then the next one is the homeless women in LA. And the explanatory variable here is the type of clinic. And the satisfaction level is the response variable. And it's an observational study, but it's cross-sectional because it was over a short-term time. And then letter D is, letter D was over the observational study for the syphilis patients, and this is absolutely horrible that this happened. Okay, so the explanatory variable is they said they gave them penicillin, right? But they actually didn't give them penicillin. And then they were looking at their autopsies to see what kind of other symptoms that they had that came out of the syphilis. So the explanatory variable is really the syphilis. This was a cohort because it was definitely over a very long period of time. It's highly unethical, especially because they told them they were being treated. And they told them that it could cure, right? It says penicillin, which can cure syphilis in early stages. But then they were left to live a terrible life and a terrible death, painful death, blindness, insanity, death, heart disease, paralysis, tumors. It's horrible. But the outcome of this study actually led to very strict rules from the National Research Act. And there was a commission that came up with this. And so now the FDA has very strict controls on studies that they can do with clinical trials. So there's people now that actually oversee the clinical trials. This is horrible. So let's go back and look at some pros and cons of observational versus designed experiments here. Okay, so randomized experiments, that some of the pros are preferred over observational studies because there's more control from the researcher. If they're well designed, we can actually say there's some kind of a causal link between the variables. A few of the cons are they are time consuming and expensive. And you can have some confounding issues that cannot be accounted for. And the reason they're not always possible is sometimes you cannot ethically control the treatment. And if you think about the study with the syphilis, that is one. You can't make somebody have syphilis, or you really can't make somebody smoke or not smoke. Observational studies are cheaper and easier. You're just gathering existing data sets. They can provide insight on whether there are associations to explore if you want to explore further with a designed experiment. Some of the cons are you do not allow a researcher to claim causation, only association, due to there's no control on the treatment, right? And so in other words, we're going to say that correlation, just because there might be a correlation between two variables, does not mean causation. And so that's going to be a big response from us on a lot of these observational studies that we're going to look at today. Oops. And all of semester. So our last example today is, I'd like you to read through study 1 and study 2 here, and we're going to answer some questions together. So go ahead and pause the video and read through study 1 and study 2, and we'll be back in just a moment. So you can see that both studies are similar. They both have an explanatory variable of smoking or not, right? What is the response variable? It's the lung capacity. They were measuring that after some time. In study number 1, is study number 1 an observational study or designed? And it is designed. You can see that because they found women who had not been currently smoking at age 20. They randomly assigned them to groups and then said 50 of you are going to go smoke for 10 years and 50 of you are not, which is not ethical, but that's what it was. In study 2, is that observational or a designed experiment? And study 2 was an observational study, right? And it says what type of observational? It's a cohort because it was long-term, specific group over a long period of time. Explain which study allows us to show a causal link between the variables. And that would be study number 1 because it is a design study. Design and control. Now we know in real life you could not do this. I'm not sure what person would volunteer to be randomly chosen to possibly have to smoke for 10 years, but maybe. What are the advantages of using a designed experiment? So you can control some of the variables. Not always all of them, but what are some possible lurking variables in study 2? Okay, so the study that was an observational study. You don't know their eating habits. They didn't see anything about that, right? We don't know anything about their underlying health conditions. And another one I could think of, you could probably think of some other ones yourself, but another one is you don't know when they when they started smoking. So we just know that they had been smoking for 10 years. What are the advantages of an observational study? One thing that's an observation, I think an advantage is people are in their natural habitat. Meaning they're not being influenced by anything. So they're just acting their natural instincts here. So people are in their natural habitat. And explain in the context of the situation why the purpose of both studies is most likely inferential. They want to be able to tell all people if smoking is good or bad, right? They're not just observing these people for some information about them. They're observing these people to be able to tell the next generation of people, go ahead and smoke, it's no big deal, or don't smoke, it's really bad. So that is the end of section 1.2. You shall go ahead and start watching the 1.4 videos.